Hello and welcome to solving quadratic equations by completing the square. Get all the terms with variables on one side of the equation and constants on the other side. Find half the coefficient of x and then square the result. Add this number to both sides of the equation. Factor the resulting perfect square trinomial. Use the square root property to solve the equation. Okay, so we want to note that the coefficient of x squared must be 1. It's very important. Work nicer if coefficient of x is even. That's going to deal with factoring, why that works out. So we want to note this is the general form that we want to work with. So let's get started. Solve the equation by completing the square. Simplify your answers. So we're lucky in that we already have, we can call this A, B, and C terms. Now we already have C away because C would not factor very nicely. Or not factor at all into this problem. So what we need to do is take the term B, divide it by 2, and square it. So in this case, we need to take the B term, which is a negative 6, divided by 2 squared. If we carry that out, negative 6 divided by 2 is negative 3. Don't forget our square. And then 3 squared is, or negative 3 squared is 9. So 9 is the number that we want to add to both sides of the equation. Because what we do on one side, we must do on the other. When we complete this step, we have x squared minus 6x plus 9. And on this side, we have negative 11 plus 9, or just negative 2. Okay, so now we can actually factor this into two sets of parentheses. This allows us to break it into x on each piece, and the positive tells us that both signs will be negative. Now what we want to do is take the number that we got before we squared, which is this right here. And that number will go into both places. The negative included, so there was our negative we had there before, and there's our 3. So this, all we did was factor, and the terms we wanted to use came from before squaring, after we took b and divided by 2. If you note, this set can be written as x minus 3 squared because it appears twice. Now we can apply the square root property to free the square. And what's going to happen over here, we're going to have x minus 3 equals plus or minus a negative 2. And if you look, that negative 2 is inside a square root, so it does not exist because a negative in square root. If we look at example 2, we actually want to get A and B alone. So to do that, we have to subtract C on both sides of the problem, leaving us with x squared plus 4x equals a minus 7. Okay, so now we have to go through our process of b divided by 2 squared. In this case, b is 4 because it is the second term, or the term that has only the x variable attached to it. So we're going to plug a 4 in for b, and we're going to have 4 divided by 2 is 2. 2 squared is 4. So 4 is the number we want to add to both sides of the equation. And actually, there was a little mistake in our problem. We actually wanted this to be a negative. And the only thing that's going to change is that we had to add to both sides of the problem. I wanted just to actually have an answer this time instead of an imaginary or something that won't exist. So when we complete this step, we're going to bring down the x squared plus 4x plus 4 equals 7 plus 4, or 11. Now let's factor this. So we'll have our x. And now we're going to search for this number right here before you square. Number inside that parentheses is what you're going to add to both sides. And now you notice that these are two of the same terms. So you can write the term once with a square sign. Okay, now we want to apply the square root property. So place a square root on both sides of the equation, leaving you with x plus 2 equals plus or minus square root of 11. And to finally get x by itself, subtract 2 on both sides of the equation. It's going to leave you with x equals negative 2 plus or minus the square root of 11. And remember, this can be broken into the answers. X equals negative 2 plus the square root of 11, and x equals negative 2 minus the square root of 11. Either answer is acceptable. Okay, with number 3, we see we actually want to make that a 6 to make it nice to factor. So let's do our little thing over here. Since we have nothing to add or subtract on either side, we're going to take b divided by 2 and square it. Remember, this is the a term, b term, and there is no c term. So in this case, b is equal to 6. Let's put a 6 divided by 2 squared. 6 divided by 2 is 3, and then 3 squared is 9. So 9 is what we want to add to both sides of the equation. It leaves us with x squared plus 6x plus 9 equals 0. Now we want to factor this into two pieces of our x's, and then we want to actually search for this number right here before we square once we divide it by 2. It's going to be a positive 3. Looking, you can write that as the one term of x plus 3, term being squared equaling 0. Now with this, let's take the square root of both sides to free this term being squared. It's going to leave us with x plus 3 equals 0. Now to get x by itself, subtract 3 on both sides of the equation. Leave us with x equals negative 3. So for this one, you only have one answer. With number 4, we do not have a coefficient of 1, so what we want to do is go through and pull out a 9 from each term, because 9 will go into each term. And that will leave the x term as having a coefficient of 1, or just x squared, minus 1x, or just x, equals, and 18 will go in 2 times. So that's what the equation looks like now. Okay, now what we can do is look at the equation as x squared minus x equals 2. Okay, so now we have a, b, and c. So let's have b divided by 2, and then we'll square that whole term. So in this case, it looks like negative 1 is b, So now we can simplify. Negative 1/2 squared is going to amount to 1 over 4. So now we can we can add 1/4 to each piece of the equation. So it's going to be x squared minus x plus 1/4 equals, and over here you can think of 2 as 8 over 4. So you have 8 over 4 plus 1 over 4, or just 9 over 4. Now, let's rewrite this left side as 2 binomials, and remember we actually want to use this as the term for each piece. That's a minus 1/2 equals 9 over 4. Notice that you can rewrite this one term as x minus 1/2 squared equals 9 over 4. As you can see now, we can easily use our square root property, making this x minus 1/2 come out of the radical, leaving us with plus or minus square root of 9 over 4. Okay, now what you can think of as breaking this into x minus 1/2 equaling plus or minus the square root of 9 over square root of 4. We're going to break this fraction apart. And when we do that, we're going to have x minus 1/2 equals plus or minus our fraction. We have the square root of 9, which is 3, over the square root of 4, which is 2. To get x by itself, we should probably break this into 2 different pieces. So we have the problem x minus 1/2 equals a positive 3/2. We're going to have the problem x minus 1/2 equals a negative 3/2. So to get this x by itself, we're going to have to add 1/2 to both sides of the problem. So over here we're going to have x equals 3/2 plus 1/2. We'll keep our denominator and just add the numerators. So 3 plus 1 is 4. And that will reduce to x equals 4 over 2, and that reduces to x equals 2. Over here we have the x minus 1/2 equals negative 3/2. So to get x by itself, let's add 1/2 to both sides of the problem. So this is going to leave us with x equals. Now we're dealing with fractions and they're the same denominator, so let's keep that on the bottom. We have a negative 3 plus 1 on top, so when we combine that, we're going to get a negative 2. And as you know, that's going to reduce to a negative 1/2. Or excuse me, a negative 1. X equals negative 1. So we were actually able to gather 2 answers from that problem. Looking at our problem, or looking at our time, we actually need to stop here